Just pulling up the issue, like I actually present it.
Yep. All right. So this is the October 11th meeting of the Resource Management Working Group. Got 4 items on the agenda, and then I guess any items that were not enumerated we can discuss after. So Vish, you were first on that list. Do you want to talk through?
Yeah, just a second. I assume everyone is able to see this. I don't intend to take a lot of time with this topic. I mean, I was hoping that we would have more of an offline discussion or email or over this issue itself. But I mean, my goal here is to like just raise awareness. For 1.8, like we sort of had a plan and we tried to stick to that plan when it came to device plugins, but we still have a whole bunch of work that's left in order to get device plugins reasonably production ready, at which point we can ask more people to consume it and like sort of give us feedback and see if it's actually meeting a more wider spectrum of needs. So in that regard, I tried to summarize based on feedback from a whole lot of you on the things that we need to get done around device plugins. I tried to like categorize them across releases, and some of them may extend beyond 110, but like I didn't really want to like go beyond 110 at this point. So some of these items actually have owners, because mostly because people have started working on that already. But the rest of them do not really have owners. So like one of my requests as part of the speed is that if you have time and if you can help stabilize Kubernetes, like please step up and like and express your interest for owning some of these items. And you can feel free to like reach either me, Jaying, or anyone else who has been active in the space, and we can make sure that you're able to do the things that are important for upstream. But otherwise, if people don't have any specific questions, I don't really have anything else to state.
Yeah, so at least from Red Hat Vish, I know we can contribute to at least 1, if not 2 of these items. And especially as some of the Solar for Nick discussions being iterated on, I don't see why we couldn't help out on getting the basic EDD stub plugin there.
But you want to hit record?
Yeah, we are recording. So I guess, yeah, from my perspective, we'll contribute here, and I just need to, we'll do at least 1 of these, if not 2 of them.
Okay, that's awesome.
So just a quick clarification, and the v1.10, when you say complete code refactoring, that means like code refactoring is done, right?
Correct.
Yeah, okay. And the other one is, should we include specifically adding more tests? Because it's more like implied in the list, but it's not a specific test.
I mean,
it's as a unit test rather than E2E test.
Oh, so that's an implicit requirement for PRC. I think the intention is to like add unit tests as a thing that will happen after a PR gets merged. It's usually a requirement as part of the PR. So as code refactoring happens, the assumption is that there will be sufficient unit testing, like reasonable amount of unit testing as part of each of those refactoring patches that we put forth. But the risk of refactoring is that we might like introduce regression. So that's why having adequate testing setup is necessary before refactoring begins.
Okay.
So I want to comment. I think like the working items listed here are the works we have discussed before. I mean, it's not necessarily this is the final plan. I think we may need to discuss the priorities for some of them, and some of the working items listed here still needs more discussions. Like for example, add power spec to allocate RPC. I think we haven't fully decided whether we need this or not. So I expect this may change over time as we finalize it.
Yeah, so from my perspective, like I know that this has been a goal for us at Red Hat to be able to demonstrate that the plugin could work with more sets of devices. And so I know that the discussion on that one's been going on. I think personally, I don't want to rat hole on that particular one too much, because in practice, all of it's useless if we haven't actually demonstrated that we work well with a dummy E2E plugin. So I'm happy to also make sure that we move our energies towards just verifying the hooks themselves work while we talk through that particular item.
Yeah, I've been meaning to like clarify the last working item. I went ahead and actually did that. So it's basically TBD. But everything else, I don't know. Is there any opinions on the rest of the items?
Can someone explain a little bit the start code refactoring? Because we haven't, I mean, this is alpha feature, alpha implementation, alpha API. And what kind of the code refactoring we want to do?
So
this is kind of special working item. So you ask TBD, the TBD about all those kind of the code refactory, but there's no guidance for what have the code refactory. There's the pending, make this as the, even like the alpha feature enable in production. There's the work to do. So what kind of the goal for the code refactory?
So the goal is actually, if you look at it, there is a working item before that, which says finalize an internal software architecture for device plugin support in kubelet to improve reliability, testability, and readability. Those are the three main categories that we want to improve upon. Like Don, I think like we discussed this in a previous meeting as to like what the specific goals are around like refactoring and why we actually need it. So maybe we can like fill you in offline on like why that is actually necessary. But there is an item before starting code refactoring, which is about fleshing out what exactly we're going to refactor it to, and whether the new model is actually meeting our needs before we actually start working on it.
Yeah, I think the start code refactoring may just fall into the like the finalize and internal software architecture, because I think that item
will be driving by that one.
Yeah, it has like a more clear goals.
I don't know if I can do like sublists. I wish I could, but this is the best I could do with GitHub's like issue tracking. But if you have any suggestions on like making it a little bit more clear, I mean, by all means, like you can go ahead and edit this issue. I just try to like give some structure to this work.
Okay.
Like what exactly?
But I think I'll post the related PRs, because we have at least 4 or even 6 PRs related to code refactoring, so it might be interesting to post them on the issue.
Yeah, I think yeah, as I mentioned, I think this is a really nice list of the working items we have discussed, but they may change over time as we finalize some of the decisions. Yeah, maybe I saw we have a long list of discussion. So maybe we can move on to the next one. Which do you want to spend more time on this?
Nope.
Okay.
All right, so the next topic here was device plugin rename, and if we want to call it, I guess the proposal here was resource plugins. I don't actually know who threw this item on the agenda.
It was me.
Okay.
So it was like, are we intending to keep this like just for devices, or is it going to be for any arbitrary resource foobar? And I think from like a long-term naming perspective, if it is going to actually be is actually meant to be used for any sort of resource foobar that sort of fits in this lifecycle model that this extension is providing, then maybe like device plugins is not the right, like device is probably not the right keyword. I just want to like hear other people's opinion on like whether they have thought about other use cases and stuff, and whether like naming it device plugins is the right thing, and is that the right way for communicating this feature?
What kind of resources do you have in mind, Vish?
So like say you want to have say software licenses. In theory, like you can just publish it as an opaque individual resource, and you don't really need any lifecycle aspects. But in theory, like you can use this framework to expose it to. Like we're not going to be opinionated on like what it's going to be used for, because like it's an extension after all. But we're just going to give guidelines, right? So in the guidelines, as we state, are we like actually imagining just basically being used for exposing hardware, like both like real hardware and virtual devices, or has anyone else in the community, excluding me, thought of other use cases for this?
So when you're saying licenses, wouldn't that also mean that you need the device plugin at the cluster level?
Maybe.
I feel like for software license, it means it may also require some cluster level controllers or like plugins. And right now we don't really have a like good use case for this support. I feel right now we since the device plugin is just introduced as an alpha feature, and we are still trying to get more experience on this. I feel a bit nervous to expand its scope to like very large scope.
So it's not about expanding functionality, which I sort of like relate to scope. It's just about how well we communicate it. I mean, I don't want like rabbit hole on that issue per se, but I was just curious to see if other people also thought about this, or if not, then we can just shelve it for now.
So I'm just wondering, maybe this is something we could delay for the next milestone before, because right now, I think as Jang was mentioning, we're still polishing and refactoring everything, and we're still very much as a device plugin, but it might evolve as a resource later. But I think
I agree. Yeah, I think the right now is to make this more generous for other resource. It is too earlier. It's not mature enough, and we also don't have the real use cases in production on demand, and we got to support those kind of things. And on the other hand, it is, I understand the motivation. It is for better communication, but I think from the user perspective, and the more important it is, we provided a feature and first and enable those kind of things. I worry at the same concern. I worry about that we overpromise once we rename. So we rename this resource plugin. People will start to use this one to think about the many arbitrary resources ask Kubernetes to support through this plugin. That's kind of we cannot handle. Yeah, that's not what we want. We want they came to us to say, here's the new type of the resource. Kubernetes, can you plan and design to support those kind of things? So then we can provide better support.
Yeah, it's a good point.
I think that's probably going to happen despite, no matter what the name is.
Exactly.
we can always rename later.
The problem is I want they came to our channel to ask us properly. If they're on their own, like fork Kubernetes and fork the device plugin to do something, then that's on their own. But I want to have that the channel, people came to us to ask those kind of things, so we know there's a demanding.
I've had no feedback from our customer community that they wanted something more generic than device plugins, and I feel like the noun device represents well the customer pain points that we were hitting. So I don't really want to change it.
Okay, awesome. Thanks for all that feedback. So I guess we can move past that topic.
Naming's hard, so I think we got a good name to begin with. All right, next topic here I think is somewhat related to a lot of the following topic afterwards. So one of the issues that came out of the CPU pinning work in the last release was we don't we lose state information across Kubernetes restarts. So Connor, you want to lead through this discussion, or I guess I can give my perspective on it as well, but we're trying to reconcile how we manage state across kubelet restart boundaries, which I feel like is also a similar problem that the following item that Vishy put out was also trying to address. So yeah,
I think that was a pretty good intro. I guess the main point is that the set of container to CPU set assignments are stored in memory in the kubelet. So when the kubelet dies and we come back, there are some CPU settings that have made it to cgroup-fs that the kubelet doesn't know about anymore. And we can re-add the containers to the CPU manager, but we can't guarantee that they'll get added in the same order that they were added in the first time around, and so we can't guarantee that they'll get the same assignment. So the idea was to either checkpoint the CPU manager state, so we have a state abstraction that's separate from the policy, so we can checkpoint that independent of the policy, which is nice. And then I guess the alternative proposal is to try to reconstitute state somehow based on cgroup-fs. But the problem that I saw with that is that cgroup-fs for containers is managed beyond the CRI boundary. And so we can't really make assumptions about how the update container resources call through the CRI was actually implemented. Like, say if there was a CRI that's not based on cgroup.
Sorry, Connor, if I just may add one note, maybe the third approach would be good to extend the CRI with the inspect container call and restore from there.
Yeah, we could. I mean, we could have this CRI implementation just tell us what it.
Yeah, I mean,
CPU set should be.
Yeah, basically 3 approaches there. So just wanted to point out the third one.
And discuss. So that pretty much brings us up to date.
So my first bias on this was that ideally we would have had a way to reconcile this from the cgroup-fs. Today, the kubelet reconciles from cgroup-fs for managing pod cgroups to figure out orphan pods. And I guess I concede your point that since it's the writer to that thing, it can be the knowledgeable reader. And so having the kubelet have to reconstitute from the container itself, I could see that kind of blurs the abstraction line, so that would not be ideal. My problem with the checkpointing thing is I feel like I'm worried that we're going to get like a plethora of kubelet checkpoint practices, and like we don't really have like one standard way of doing that right now, to my knowledge. And so, like if in the follow-on issue of Vish, I feel like we had the same problem with where is the kubelet going to track anything that would have been kept for devices across kubelet restart boundaries. And so, I don't know, generally I'd like to figure out a way that if we do checkpoint something like this, that we don't do it a ton of times in a ton of different ways.
Yeah, if we could unify the checkpointing in the kubelet. I guess I don't know a lot about the existing checkpoint support. So maybe if someone has looked at that code, they could advise whether it can be unified. Like if we
that, as far as I know, like there is no really a unified checkpointing model. Like CRI does its own thing, storage modules do their own thing. Yeah, I think that's, and for device plugins, Jai introduced a separate thing.
So this is done, and I can summarize what's the checkpoint. So we try to avoid the internal state checkpoint by Kubernetes. The couple region for in the history, the first thing initially, we don't have the good versioning. We don't know what kind of things because everything's moving target. Like before, we even don't have the CI interface defined. So how Kubernetes will communicate with runtime is not well defined. Right now we have the CI in alpha, and also before we don't have the CNI, and also in beta before. So we also don't have today we don't have the storage interface between Kubernetes node and the storage. So to generate arbitrary of those I view like the checkpoint, it is just similar as the API, all the requirements like the API, without the well-defined version, the API, and between modules on the node. I prefer now to have the standard way for checkpoint, especially for internal state. So once we have those API, we can start thinking about what kind of things you want to checkpoint. So for this kind of the CPU affinity checkpoint, I really think about that's the way to recovery from the running state when Kubernetes state start. This is not just first one people want to recover from the running state, and the CPU assignment is just one of those kind of things. And I think, and especially this is easy to recover from the running state. I understand there's maybe have some requirement for the CRI change. We could start to talk about those kind of things instead to go through the internal checkpoint. But if we must have to do the internal checkpoint, like for example, for the CNI, some of the CNI change, we prefer at this moment each component, each plug-in implementer to implement their own and like in the lowest level. So then we don't have the backward compatibility issue and the forward compatibility issue because they maintain that feature for each release at this moment.
Yeah, I mean, personally, don't know how I feel. Like my bias would be that we have the ability to inspect the container via the CRI. And make it that the runtimes themselves can report back to the kubelet their actual state.
Every feature added to the CRI is going to, I don't know what the bar currently is, probably Don can clarify, but like every single feature added to the CRI requires support from a whole bunch of runtimes. Maybe that's easy.
So like, we have a method today to update the container's resources, right? But we don't really have a method that like lets me know what the container think its current resources are. I struggle to think that that's like going too far, to be honest. I don't know. I'm open to other opinions, but I would prefer that versus us writing our own state file, for example. And in general, the versioning constraints around state files, like I don't know how most people will handle this, but like at least across kube releases, we'll probably still drain nodes and treat them as installs for entirely new nodes. I think GKE would work similar. So I would expect all state to be wiped away across upgrade boundaries.
Yeah, but I don't know if that's true for other users though.
Oh, I know. I think how I would want us to work, that's how I would want us to work. And I think at GKE, you guys do rolling node upgrades. So I think that's conceptually how you may work. But in practice, like I would prefer that I can just go and ask the container runtime itself to report back via some inspect container call.
Yeah, I think this is probably a feature request for the CRA maintainers, and we should probably get feedback from them, right? If this is a viable option.
Would we find this useful for devices, Jeff?
I mean, devices are not really touching C groups at this point. We're sort of like relying on Kubelet to take care of Kubelet and the container manager to take care of all the C group magic. Unless the feature scope changes, at which points device plugins also want C group interaction, I don't think it's a requirement.
Yeah, right now we used some internal checkpoint. It's an interesting question whether we can also recover this from C group. But right now we don't need this.
But you guys for the device plug, not device plugin, for GPU monitoring, actually right now you are dependent on the C group. So they do have that go through, yes. But that's part of the Kubernetes.
Well, the matrix is part of the C advisor.
Matrix is like, I mean, introspecting the kubelet is a complex topic, and I don't know, maybe like that might be a rabbit hole for us. Like in terms of just the control plane logic, we don't have a specific requirement there. But if we look at it from slightly a meta level, which is not looking at just C groups, but like as you described earlier, Derek, like the fundamental idea of like provisioning resources for a pod before a pod is going to run, I think that's a common requirement, right? So we can fail early rather than like trying to provision when a container starts. Like, so that's a meta requirement. And then once we provision it, where do we actually checkpoint it? Do we wait for the first container to start in order to checkpoint that information? Or can we like checkpoint it much earlier? So that's another like meta level topic, which I think is like relevant to device plugins too.
Yeah. So just so I'm not mistaken, the device plugin module today does have a checkpoint file you write out to, correct?
Yes, we currently use this checkpoint file. But if CRI can provide this pod container to device bounding information, it should be easy for us to switch.
Mm.
Yeah, the thing is,
but I'm thinking that probably the checkpoints could still be useful even if the container
Can you
wasn't
help
created.
How CI help you? Because then you are go through the device, because CI have no idea about this is device plugin. So you are going to go through, anyway, you have to go through Kubernetes.
Yeah, we need to get the container information from Kubernetes, not from CI directly.
Even then, it's like, from a lifecycle standpoint, Kubernetes gets a pod. And then before the pod is even known to the CRI, you go through the container manager, you do a bunch of allocations. You allocate probably CPU sets and probably memory and like and all that. And then you go ahead and like talk to device plugins in the future, where you would get a whole bunch of devices allocated for the pod. And if either of these steps fails, then you're going to fail early and like say that the pod cannot be run on this node. So that's sort of like extended feasibility checks, right? In addition to what failure runs.
Yeah, I agree. I mean, I was saying that we wanted to have a pre-planning phase where ideally we could do CPU and device assignment topology where before ever actually starting this thing, and have it be done in some code areas that knew of each other. So I guess what I'm wondering is like if in the interim, like right now device plugins are alpha and you guys are checkpointing to a file, is there an objection then if we just do the same for the CPU manager while it's still in alpha to have it checkpoint to a file, and at least while it's alpha, there's no actual upgrade guarantees or anything being lost there with respect to versioning. Is that a way forward where everyone would be comfortable?
To us, we don't really care. Like that sounds some implementation, internal implementation.
The CPU management internal implementation, that should be okay.
Yeah, exactly. Okay.
Yeah, I will okay with it.
I was just toying with an idea, and this may not be feasible for some reason. The idea came into my head, but like storing this in the container status and the pod status, pointing this information into like some equivalent of an annotation in the container status.
So the thing is, the one thing to keep in mind is that container status or like any updates to API server happens asynchronously. So it's not like I don't know, and it is possible, I guess. I don't know which field you would sort of overload all this into, of the new field. But I mean, we have rate limiting on updates to the API server, so it's going to be asynchronous. And what if that update gets lost?
Yeah, I'd like to avoid that, Seth, to be honest. And then also, like, I'd like to keep it that when these things are dynamic, that like they can be dynamic at a granularity that's different than having to report back to the API server. So yeah, I guess for now, if there's no issue with checkpointing to a local file, I guess I'm fine with that if we're actually no worse than device plugins, which I had not kept up to date with. And then I guess we'll proceed that way for now. I guess that kind of talks through that topic.
Okay, so sorry. So if the file checkpointing is at this point okay for us, could you take a look at this PR and see how do you feel about it?
Yeah, I'll take a look at it. I wanted to just actually like discuss it before.
Yeah,
the group.
of course.
Yeah, I'm going to take a look at the checkpointing format too, and at least like try to have some consistency between.
So in this proposition, I just use basically the same thing that is used in the device plugin. So this is a JSON.
Okay, sweet. Yeah, and that's the thing I was going for. At least like when you want to debug something.
Yeah, exactly. Additional assumption was that if the file is for some reason corrupted due to the mismatch between assignment and what policy requires, the whole file is basically tossed away and we start from scratch.
So, Vish, I don't have it off the top of my head, but for the device plugins, can I control where the checkpoint file is?
It's right now it's in the same directory as the socket files. So it's a privileged directory. I mean,
it's not configurable, right, Jane?
It's barely Kubernetes.
Yes. Well, it's I mean, we can change it if we want some other place, but it's right now it's located there.
Right. So it's basically root directory of kubelet / a fixed file name, right? So it's not.
Yes.
Okay.
Okay. So as long as our checkpoints are all staying somewhere co-located with each other, I'm fine with that. Okay. All right. Well, that answers that topic. Moving down the list here, I guess we had one final topic, which was what to do with kubelet restarts and device plugins. I don't know, Vish, if you want to kind of summarize your proposal a little bit, and then I was trying to think about it as well last night.
Yeah, let me try to recollect as much as possible and give a summary. I think the top level problem is that we sort of advertise this way of deploying device plugins through daemon sets. So then a natural thing for any Kubernetes user to imagine is that you can deploy a daemon set, but you can also like delete the daemon set and the resources would just magically disappear, right? Like that's a great demo experience, and that's probably also a great, I don't know, like a great usability story. But the problem is our system is not set up to handle resources that disappear dynamically. And if resource appears dynamically, once we have extensibility through quota, limit range, and so on, it can probably handle that seamlessly. But whenever we get rid of resources, like it's not something that we take into account across the stack. And so getting rid of resources can happen due to two reasons. One is a resource goes bad, like a set of a memory bank has gone bad, or like a bunch of CPU sockets have gone bad, or a disk went bad, or in this case, like a GPU went bad. In any of those cases, the capacity reduces, but the resource is still there. There's also the second scenario where the overall resource itself disappears. That's not the case for some of the first-class resources, like CPU, memory, and storage, but that is quite likely a scenario for extended resources. Maybe not GPUs, because I don't realistically see why that would be the case, but maybe there's some like unknown use case in the future where like people want to install and like dynamically uninstall resources and so on. And in addition to this, there's also this other point mentioned where on a given machine, you might have different classes of resources, one that is important, the other one that is not important. So the ones that are not important should not like affect the functionality of rest of the important resources. Again, like this is hypothetical. We don't have a concrete scenario here. I'm trying to summarize whatever was mentioned in the issue. So the proposal that I had, and there are alternative proposals too, is that one of the proposals is that we don't like automate getting rid of resources or like deleting resources that have previously been advertised. So the workflow is somewhat like this. So as a user, you install a device plugin. The assumption is that the device plugin is important, and like failures as part of the device plugin are something that you would be interested in looking at, and you don't want to like silently ignore. And there's also other assumptions like we cannot require users to have their own like parallel monitoring stack in order to guarantee that the rest of the Kubernetes stack would function properly, because we don't like make such requirements today. And so that's one more assumption there. So the proposal is that if say a device plugin goes bad, as part of kubelet lifecycle. And the way the kubelet knows that a device plugin went bad is when the device plugin does not respond, or if the device plugin fails to register, right? And the way the kubelet is set up now is that whenever the kubelet restarts, device plugins are expected to re-register. At this stage, kubelet does not know which plugins previously registered, but there is an implicit assumption here that kubelet would know moving forward. So when kubelet knows which plugins have registered to it, and when it restarts, it'll wait for those plugins to re-register with a configurable timeout. And if the plugins don't register with kubelet within that duration, then the kubelet taints the node, saying that there is a problem in this node. It prevents any future pods from running there. It lets the existing pods run because it doesn't want to disturb workloads. And at this point, a cluster administrator or some sort of automated workflow that the administrator has deployed is expected to come in, step in, and repair the node. And maybe the node gets repaired and it goes online again. Or if the node does not get repaired, the expected workflow for removing the device plugin from the node is that there would be a graceful drain happening. And then the device plugin daemon set is if daemon set was used as a deployment model, then that node would not be part of the daemon set scheduling pool. And so a drain followed by removing of the device plugin gracefully, and then the kubelet gets restarted, at which point, then the kubelet gets provisioned again, at which point the kubelet, the device plugin has been safely removed from that node, and the node has been put back into the system. So this is one proposal. The other proposal is somehow figure out a way to dynamically handle all this. The proposal is not fully fleshed yet, but the idea is okay, we don't add this burden of requiring a cluster administrator to step in. And if a user decides to say instruct Kubernetes to ignore device plugin failures and then just move on, then we would probably kubelet would probably go ahead and do that. But there are some gotchas there which have not yet been flushed out. So I guess one of the main questions is there is a usability hit if we go through the taint and graceful drain process. But what is the general sense that people who manage Kubernetes in production have today? Do they prefer having explicit failures that needs human intervention, or would they prefer some auto magic that will make some decisions for them?
So one of the things I was wondering when I was reading your proposal or your recommendation or your for the first plugin lifecycle management is if I have the following use case where I'm a data scientist, right, and I launch a training job on a node, and at some point the training job takes a lot of memory or too much memory and makes the device plugin crash. Because OM or something like that. Is that first of all, is that a realistic scenario?
I don't think so. I mean, you're sort of having an extended control plane in the form of device plugin. So it's up to you to set high priorities and make sure that you're running device plugins ideally in the guaranteed cost class so that the device plugins don't get impacted by OM. And you have also set node allocatable and so on. So you have a reasonably stable Kubernetes deployment which can protect certain critical jobs from OMs, and that's sort of a requirement.
So my general feeling is if we can support dynamic unloading device plugin with reasonable complexity, I think it will give us more flexibility and also allow us to support a wider range of devices. And I think we should be able to support it with reasonable complexity. For example, I think if we can introduce some special naming convention for device plugin resources, it should be relatively easy for us to support dynamic unloading.
So I'm trying to think.
So if a device plugin goes away, and we remove that resource, what happens? What do you imagine happening to the already existing pods which were using those devices?
So in our design proposal, we mentioned for the pods that are already assigned with the resource, they should be we shouldn't interrupt them. They should keep running as long as the devices are still in good state. But we will remove the resource from the capacity, from node capacity, so that future pods will not be assigned to that node.
I see. So I think one issue I see with it is, for example, like let's say a container needs a restart in that in a pod which had a device allocated to it. What will happen in that case? Like, because now we have the capacity as 0, but we had some pods or containers which are already using that devices. Like, so I feel that is a bit confusing in the sense that
yes. So for pods that have restart policy, always when they restart, they will fail because the capacity, I mean, the resource is gone. But this is still like, I think, a limited failure case because the node can still be used for other resources.
Also, aren't all bets off once as a cluster admin or as a user you've removed the device plugins? I mean, we can say that it's reasonable to say that we won't stop your pods or your containers that are using the device, but if they restart, then all bets are off. The device plugin is not here anymore. That's your problem, right?
Yeah, I also feel it gives us more flexibility in terms of like upgrade and like yeah.
I add a comment. One comment. I think that proposal which propose that actually have the one assumption: the node is not shareable with some other workload. So I'm not sure that assumption it is right or wrong, but because you have to notice that if there's a shareable node, not just the ML job, for example, take the GPU as example, and not just ML job is running, there's some other job is running on the node. So you are kind of lose the more capacity from resource capacity from that cluster. You're forced doing those kind of things, even you just kind of want to remove device plug-in from that node. You want to dynamically allocate some other node.
Right,
so that's kind of difficult for the cluster management.
Right, so I theoretically agree, but in practice, like the use cases that we have heard so far are like for device plugins are for like managing these sort of like specialized hardware, which are probably going to dominate the cost of the machine, right? Like GPUs dominate the cost of the machine, and like I would imagine like any of the high performance NICs to be the same case. Like the use cases we have heard are ones where these hardware are like the primary reasons like CPU and memory exist on those. So
yeah, for GPU that may be the case, but for other types of devices it may not always be the case.
There is one case we know of that needs both, and that's the people write hardware accelerators to handle deflate and inflate of web pages. Did you see that request? I mean, that's going to be an FPGA and some kind of like Nginx worker pod that goes with it.
So would they be okay if like the FPGA disappears underneath their feet?
No.
So I think that's the discussion primarily here. In that, would we prefer having like explicit errors that sort of like fail loudly and like have the cluster administrator step in either manually or like through some automated process that they have explicitly set up, or would we like just remove the resource and say that the behavior like Renaud mentioned for the pod is sort of undefined once this happens, but then like the node will keep marching on, and the node will probably like raise enough events and probably monitoring signals and so on. But like this is something that administrators have.
From my perspective, I feel like I'm most likely going to just manage this node as an atomic unit, and if any of the devices report as unhealthy or go bad on that node, I'm probably going to take that node out of commission, mark it unschedulable, and look into getting a new node, and not really repair the existing one.
Yep, I would agree with that.
So like that's basically what I imagine our playbook would be on this. If any device plugin on that node reported unhealthy, I'll immediately mark it unschedulable and drain it in practice.
Yeah, and so the use cases that I think we have on GCP, which is primarily at this point just GPUs, that would probably be our situation. Probably not like try to make GPUs disappear. So I guess at this point, we basically need feedback on other use cases of device plugins where this might be necessary.
So I think I feel the general consensus is if we can handle dynamic resource removal, it seems a better model. I think which major concern is the complexity that requires.
Well, no, it's not just the complexity. It's a software after all, right? So we can figure out a way to deal with that. My major concern is like maintainability as a cluster administrator. Like if things are, I would want like very predictable failure models that, like as Derek was saying, I can put in a playbook and people can go through that and like know like realistically what went wrong, rather than like having to merge 3 or 4 log streams and event streams and find out like what are the series of events that happen and like why do this pod like restart and fail to start after that and like sort of got stuck. Because if the pod gets evicted, then it gets run on a different node. Whereas if the pod is like sort of stuck in this weird state, I don't know. I'm hoping it's not weird in that like we'll probably evict the pod at that point. But like that's an extra different failure scenario that we have to educate our users and educate the rest of the support folks, right? So my gut feeling is that like having an explicit failure model is probably easier to explain. That said, like if we get feature requests in the future where people say that, hey, I want this dynamic model and I have this use case foo bar, then we can possibly extend to that, right? And that like we're not precluding that option, but all we are saying is like, okay, we can support a dynamic model, but we'll support the dynamic model and justify the added complexity once we actually have concrete use cases for it.
So, quick question here. I completely understand the need for, and I agree with the fact that when your GPU or your device goes bad, you want to mark your node as unhealthy and not schedule anything. That makes a lot of sense to me. But I'm having a problem wrapping my head around the use case, or what would be an example of an admin removing a device plugin? I mean, except for updating the device plugin, what would be the use case for that?
As far as I know, we don't have a use case, and that's probably why this conversation is even happening. Because if we had like concrete use cases, then we could like come to a conclusion much easily. Jeng, like correct me if I'm wrong, we don't really have any use case that's been expressed in the community that requests dynamic handling, right?
Right now we don't, but I just feel like if for a single device plugin failure, we mark the whole node as not usable, like at 10. That seems like a propagate failure too much. For example, I heard some people asking about the use case to support FPGA, and because the FPGA can have different properties on a single node, so they are considering to register multiple resources just for FPGA. And so if one resource goes bad and we just mark the whole node as not usable, my worry is like if for some reason some buggy device plugin could cause more damage.
But no one's saying that the code out of the box is the one that goes in. Like no one's saying that the kubelet goes and marks itself unschedulable.
So what if we like taint the node with just a taint which says that okay, don't schedule pods which require device plugins?
Yeah, that's the proposal. The proposal is not to mark the node.
We cannot hear you guys.
Oh, so Rohit was asking like, what if we taint the node? And I was just telling him that like the proposal is to actually taint the node, so you can have like pods that tolerate the taint and continue running there. So we're sort of like, I mean, this is all up to the users, right? Like the proposal that we have now is up to the user to define what the process is, right? Like the user can add a taint, they can mark the node unhealthy, they can do a whole bunch of things, but it's basically up to the user to sort of define a lifecycle process at that point. And we are just reusing whatever existing lifecycle semantics we have. Whereas for the dynamic use case, we do have to add some more features to the kubelet. So I know I'm still a little bit. My gut feeling is like maybe we should just wait for people to express this use case before we add it.
So my only problem with the model that you proposed is the part 5, when again the cluster admin wants to remove the device plugin and he actually has to go in and drain the node, etc. I mean, that feels like a really weird model and pretty counterintuitive. If it's just like device health, then I completely understand and I agree. But
that's just one way, right? Like, I mean, that's just one illustration. There could be a more complex illustration where, say, you run a tool that figures out what went wrong, like sort of fixes it, like removes a whole bunch of checkpointing files and so on, and then like you sort of do an online machine repair and then like get the node online again. You're welcome to do that too. But I was trying to be a little bit generic and like sort of describing the worst case scenario. But you can like sort of refine the process, right? Because the process is not controlled by Kubernetes.
Yeah, I mean, the remove the plugin from that node is basically like if that node is still useful without that device. But if that node is actually not useful without that device too, then you probably want to get that device working and get a node working with that device.
Yeah, just having that routine which says this like node is not usable for this device makes sense.
So the tainted node will mark the node not available for all resources, not just for that resource, right?
Unless you can have a pod that tolerates the taint, and you can have like admission controllers that inject tolerations and so on. So we have enough building blocks to like define a process that works for different device plugins with just like taints and tolerations.
But usually we expect the pod to already be configured to avoid the taint nodes in most cases, right?
Yeah, by default, if the taint is set to prevent scheduling for new pods, then that will be the case. But I think like both Derek and my point and others' point is that is most likely going to be the scenario for the devices that we know of today. And until we know of different set of devices that do not have this constraint, maybe that's good enough. And even then you can mark a taint which doesn't like really prevent pods from scheduling. So I feel like that we have enough primitives there.
So my feeling is like if we want to implement this, we also need to add code with some complexity to taint the node. If device plugin, some device plugin.
But that's the of the node itself. That's the separate cluster management. Yeah, okay. Whatever cluster management things. So I feel like we don't understand the on-demand request at this moment. So dynamic removing and all those kind of things is not, at least for now, it is not the high priority. I think we can wait. We can wait and then waiting for the rest of the demand.
Oh, so you mean we don't have to implement the part that taint the node?
Who want to use those kind of things? And they could, based on those kind of decision, their production requirement to decide how they're going to manage it.
Yeah, the assumption which I should probably like go and fix now is that device plugins will taint the node.
Device plugin will taint the node? You mean
it's out of tree, right? Like upstream Kubernetes is not being opinionated on the process.
We should. I think there's let's make this more clear. So the device plugin report there's healthy on the node, and there's some of the cluster management tools or system will taint the node, and it is outside our core system, and whoever admin, that's their how they are decided. It's not a device plugin taint the node directly.
How will device plugin taint the node when its device plugin is not working?
Yeah, that's right.
Really? I cannot hear you. Repeat.
Yeah, so Rohit was asking the same question that you were the same. He was asking the statement that you said as a question, Don. I agree. Like I sort of got distracted a little bit there. That only works for scenarios when a few of the devices fail, and not if the device plugin itself outrightly fails. I mean, in that scenario, if the device plugin is not registering, then in either the kubelet has to expose the node health because the kubelet sort of knows that the device plugins do not register, or there should be some other way for other parties to introspect whether the device plugin has registered with the kubelet. We should probably hash that out a little bit more. We only have 2 more minutes today.
Yeah, this is that's why I keep asking this question. I think this is part of the whole life cycle to management. We need to have so kind of like the way kind of introduce one way to on demand to have this kind of the way to add device. But on the other hand, it's not symmetric. Then we don't have like the hardware removed. I mean, so I agree with that when we don't need a handle for the production support, we don't need a handle on-demand device plug-in remove or deletion. But I think that we need from the architecture design, we need to think about this kind of, this should be have the full story for the user.
Yeah, this is a goal for 1.9 that like defining a recommended use guide for using device plugins in production. So I'd assume that we'll have a solution for it, but we just have 1 more minute. I don't know if we can actually hash out that solution.
Okay, so I guess we are running out of time, so like we can continue the discussion in the issue. So I think the main thing we need to settle down is whether we want to have the device plugin framework to support the dynamic resource removal, or we just tell users like they need to take this extra administration steps to remove the resource.
And the second.
So the recommendation is the second, but we need to like flesh out how exactly this would work. At least we should have a solution that we think we can realistically support in production, and sort of like try to recommend that and refine it.
Okay, I think we can continue the discussion in the issue. Okay. Okay.
All right, well, thanks everyone for a lively discussion today, and I'll post this up to YouTube for those who zoned out at parts and want to catch up later. But thanks again. I'll talk to you later.
Thank you.
Thanks for organizing.
Thanks.